What's up guys? Welcome to my channel Science World. This is Dhumbhi from Science World. I hope you all understand my previous video regarding quantum mechanics and atomic structure. Now I am presenting some information regarding rules for filling of orbitals in atom. Means what are the rules we should be followed to fill an electron in an orbital? The filling of electrons into the orbitals of different atoms takes place according to Aufbau principle. This Aufbau principle is based on Pauli's exclusion principle, Hund's rule of maximum multiplicity and relative energies of orbitals. Now we will discuss one by one. Firstly, we discuss about Aufbau principle. The word Aufbau in German it means building up. The building up of orbital means the filling up of orbitals with electrons. This Aufbau principle states that in the ground state of the atom, the orbitals are filled in the order of increasing energies. This means, in other words, the electrons first occupy the lowest energy orbital available to them and then it enters into higher energy orbitals. Only after filling lower energy orbitals. This is the diagram showing the filling of electrons on the basis of Aufbau rule. Here the 1s is the lowest energy state and 8s is the highest energy state, where the filling up of electrons takes place from 1s, 2s, 2p, 3s to higher energy state of 8s according to this diagram. This is the Aufbau principle. Next, it's Pauli's exclusion principle. This Pauli's exclusion principle was proposed by Austrian scientist called Wolfgang Pauli in 1926. The number of electrons to be filled in various orbitals is restricted by the exclusion principle. According to this principle, no two electrons in atom can have the same set of 4 quantum numbers. This means that the two electrons can have the same value of 3 quantum numbers n, l and m. As we know, n means principal quantum number, l means azimuthal quantum number, m means magnetic quantum number, but must have the opposite spin quantum number. The restriction imposed by Pauli's exclusion principle on the number of electrons in an orbital helps in calculating the subshell. Means this helps in the calculating the subshells in an orbital. This Pauli's exclusion principle can also be stated as only 2 electrons may exist in the same orbital and these electrons must have opposite spin. Here in the diagram you can observe what is Pauli's exclusion principle. The first one showing 1s2 orbital which is having opposite spin, 2s2 also having opposite spin. Here in 2p2 we can see the 2 electrons in an orbital, means in first orbital having one spin and second orbital having another spin. After filling this, their pairing up takes place. In this, firstly their pairing up takes place. So the first one is the correct for Pauli's exclusion principle. This is about Pauli's exclusion principle. Next comes to the Hund's rule. This rule deals with the filling of electrons into the orbitals belonging to the same subshell. Here we can see that is the orbitals of equal energy called degenerate orbitals. What Hund's rule state means the pairing up of electrons takes place in the orbitals belonging to the same subshell does not take place until each orbital belonging to that subshell has got one electron each. That is, it is singly occupied. In this diagram of Hund's rule, you can see within a subshell place 1 electron per orbital before pairing up. Means in 1s, 2s, 2p here you can see the pairing up takes place after filling up of 1 electrons to each orbitals. In second one, no pairing up takes place. The pairing up takes place before filling up of 1 electrons to each orbital. So this does not follow Hund's rule. The first case, it follows Hund's rule. Only Now we comes to electronic configuration. What is electronic configuration of atom? The distribution of electrons into orbitals of an atom is called electronic configuration. In the periodic table, we can see the electronic configuration of elements, and they followed by Aufbau principle up to only vanadium. You can obtain correct electronic configuration for elements up to vanadium having atomic number 23 by using Aufbau diagram. But we cannot obtain electronic configuration on the basis of Aufbau diagram after 23. Means we will come across some exceptional electronic configuration. We have exceptional electronic configuration for chromium and copper. On the basis of Aufbau principle, chromium having electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d4. For copper it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d9. But the correct configuration of copper is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. For chromium it is 1s copper it is 1s2, 2s2, 2p6, 3s2, 4s1 and 3d10. Why do you think these oddballs would do that? These arrangements give chromium a off-filled d subshell. For copper it give filled subshell. Means filled and off-filled energy subshells are more stable. Here in the chromium we can see 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. Here 3d5 is off-filled electronic configuration. It is more stable. In copper we can see 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. It is having filled electronic configuration, so it is more stable. Here we can see the exceptional electronic configuration for copper and chromium. This is about electronic configuration and exceptional electronic configuration of some elements, and I hope you understand my previous video about quantum mechanics and atomic structure and rules for filling atomic orbitals. Guys, please don't forget to like, share and subscribe my channel. Thanks for watching guys.